Welcome to Naturistic, a biology podcast focused on ecology, evolution, plants, and animals. I'm Nash Turley, a biologist, and each episode I research a specific subject and present what I've learned to my co-host, Hamilton Boyce. This episode, we discuss old-growth grasslands. Howdy-ho, Hamilton.
What's up, Nash Turley?
Any music or food-related revelations on your end in the last month?
Ooh, music or food revelations. Well, I sent you that cashew paella recipe.
Yeah.
Which
paella is Spanish, right?
Yeah.
I think I've kind of toured the world on slowly of different food styles. I've been doing Chinese and Indian and Thai is sort of what I've gotten to. I think European foods have sort of not been on my radar at all.
Yeah, there's some good stuff. I mean, you've got, anything around the Mediterranean is usually pretty solid, I think.
Yeah, for sure.
British food, total garbage.
Not exactly going to, order the vegan Finnish food and, enjoy my cultural roots of Finnish food. Probably not on the top of my list.
Right.
Plus, I don't have anywhere to bury a shark.
Bury a shark? Is that like how you cook Finnish food? There's
a famous dish that's from that part of the world that's just like you catch a shark and then you bury it for 8 months and then you dig it up and eat it.
Oh my God.
Sounds horrible.
Do you have to bury it in anything particular or just anywhere, any old place?
I don't know. There's probably something specific.
Yeah.
In Iceland, did I ever tell you about coming across someone cooking outdoors in Iceland?
I don't think so.
So there's one part of Iceland, there's lots of geothermal activity. And so like the ditches along the street just had like near boiling water in them. And in the morning, all of the steam would be rising.
Yeah.
So out of total random chance, we stopped on the side of the road just to look around. It was like a beautiful setting, like it is almost everywhere. And looking at all the steam. And then I looked in this ditch water and there was just a bag of salmon being cooked, being sous vide in the ditch on the side of the road.
Whoa. Was there a chef nearby or just
I didn't see
someone
anyone,
left it to come back to?
Yeah, it was like they probably, woke up early to put it there and then would come get it for lunch or something. But
that's amazing. It's like the slightly classier version of dashboard cooking.
Yeah, totally. Lots of the houses would just have a built-in hot spring because they would just pipe in, boiling hot water from the ground to heat their house and to just have like a sauna.
Yeah.
Pretty rad.
That is very cool. It's like how in the Northwest, you don't need a refrigerator. You just put stuff on your porch.
It's funny how little that probably happens. And it's so funny that we like spend all this energy to heat up our houses and then put a cooling box inside that hot box. So it's just like double energy.
Yeah. Like first we're going to make this outer layer very hot and then we're going to find this inner layer and we're going to make that very cold. And that's pretty much going to match the outdoor temperature.
Yeah.
But they're not going to be connected at all. A lot of insulation.
Right. If there was just another box inside the fridge to like, keep your muffins warm, that would be extra absurd.
It's in the freezer.
It keeps them real dry while they're staying warm. So
right.
you got to do it.
Yeah. My question for you was going to be, what about you?
Well, I perhaps for the first time made a standalone veggie broth.
Oh yeah.
It was like a ramen recipe. And the idea of doing that always seems so weird to me because you like put all these vegetables in it and then you throw them away. It's
right.
Like, why don't I just eat the carrots instead of put them? But I tried it and it was, it's cool. It basically just like carrots and onions and garlic and celery and some other stuff and just, boil the crap out of it and then mush it all out. And then you're left with broth. And I had a bunch of it. So I just put it in jars in the fridge and it's coming back to it where I come to appreciate. It's like, oh, I just got this jar of soup. And then today I've been doing where I just add noodles and some onions and carrots and that's really fast and add some chili oil. So it's spicy.
Yeah. Nice.
It's like, wow, this is really good. And that was really fast. So
nice.
Something I might do more of. Also, if you keep all your little rinds while you're cooking in a bag in the freezer, then you can use those.
Yeah, exactly. That's what we sometimes do. And I was just going to tell you about that life hack, but you already hacked it.
I've done it at times. And then I think at one point I had one in there that was just been frozen for a really long time. I was like, this doesn't seem like food anymore.
Yeah, definitely. Yeah, that
so
happens.
You got to kind of like keep
75% of the time for us. But,
right.
If you get some veggie broth 25% of the time, not bad.
Yeah. The topic for this week is grasslands. And the first thing I wanted to point out is that both of us live in areas that are grasslands, except probably most everyone that lives around us doesn't know that.
Right.
And we'll sort of circle back to the California grasslands at the end, but Florida would have been grasslands, but, is barely at all anymore.
Yeah.
And I could definitely do a whole episode about longleaf pine savanna, and maybe we will. So sort of leave that longleaf pine savanna of the American Southeast sort of unspoken for the rest of it. But yeah, we both live in grasslands.
Yeah. That's cool. And kind of mind-blowing based on our actual direct lived environments.
Yeah. Is that like, would you think of Los Angeles area as being a grassland?
I would not think of it as being a grassland.
So what do you think of as grasslands? Like, what does that evoke?
I mean, I definitely think like prairie. I picture, big flat fields, definitely, not a ton of trees, maybe some Terrence Malick storylines happening, some sunsets. And
who is that? I don't know that name.
He's a director. Like Days of Heaven is one of his kind of classic films from that style. Days of Heaven is very much like grasslands. It takes place like kind of on a farm, like out in the fields and stuff. So a lot of grassland vibes and stuff.
Yeah. So you mentioned a couple of keywords there, which is not a lot of trees. So that's like key to the definition of a grassland is, not dominated by trees. And then you said prairie, which is a common synonym. There's a bunch of other words that are essentially types of grasslands. Savanna, which I mentioned. Shrublands can be considered grasslands. Tundra, which is actually one that I hadn't really realized is often considered grasslands, but high elevation or high latitude areas fit the definition of grasslands.
Okay.
Woodlands, which are kind of like intermediate between a forest and a grassland. Meadow, and then steppe is another one, which maybe you've heard of. Like various places like to call things steppe, especially in Mediterranean regions. If it's more kind of shrubby, they'll call it a steppe.
Steppe. I have not heard that one.
The numbers I've seen it vary, but somewhere between like 25 and 40% of land on Earth are one or another type of grassland. And if you lump all those together, they're basically the majority or the largest, the plurality of ecosystem type is a grassland.
Wow. Is that like based on what is currently around or more like in a historical context?
Well, I'm not sure. And that's probably why the numbers vary so much.
Yeah.
Because you could like classify it as what could be considered a grassland or what would have been. And sometimes those are very different. So like looking at the United States, for example, a lot of the southeastern US would have been grassland, but now isn't. So how do you categorize that?
Yeah.
So that's, people make different choices. That's probably why one reason why the number varies so much.
Right.
Some hot spots for grasslands, of course, western and central part of the US. And then if you're, considering those tundra, you have a lot of Alaska and northern Canada. And then South America actually has quite a bit of grasslands too, in the northern part of South America and the southern part of South America. So basically everything except the Amazon has a lot of grasslands. The vast majority of Africa has grasslands except the Sahara Desert and the like Congo. Everything other than that is basically grasslands. Most of Australia, and then a lot of Western China and a bunch of the Middle East, and is all grasslands as well. And then a huge swath of it up in northern Russia.
Okay. So like not really too much around the equator. Would that be accurate?
Yeah. Cause one characteristic of grasslands is they're often caused in part by lack of rain.
Right.
So they're xeric, I guess is the ecological word, just pretty dry. And that's one thing that can prevent tree growth. And so around the equator or sort of certain latitudes, you get tons of rain. So there's not often grasslands, but there are tropical grasslands, even where it's pretty wet. And those are often then maintained by fire or by grazing. So without either fire or grazing, they would maybe enough water to get forest.
Right.
And that's actually what a lot of the Midwestern US is like, there's basically barely any grassland left anyways, but the areas that are left often are forests now because they don't burn. So it's wet enough there that you can get trees growing, but without grazing or fire, it just turns into forest.
So historically, would that have been buffalo grazing? Or who was eating the tree saplings, I guess?
Yeah, I think bison was the major sort of large grazer in the Midwest in sort of more recent history. You go back a little further into like the Pleistocene when there was a lot more big animals, then there was a bunch of things, or giant ground sloths and armadillos and all sorts of crazy things.
Right.
But more recently, it would be pronghorn, which are more in Western prairie, and then bison, and then, deer and other things as well.
Right.
And then, other herbivores can play a role as well, like rabbits and small mammals and stuff can sometimes play a role. Maybe not as much in suppressing tree growth, but they definitely have a big role shaping the other plants.
Right.
So we mentioned open landscape. That's like key to the definition of a grassland. Being dominated by grasses seems sort of obvious, but it is a little more complicated than that. There's a broader term called Gramanoids, which are 3 different related families of plants. It's grasses and then sedges and rushes. They're all related things that look grassy that can all play the role of grasses.
Okay.
Normally the sedges and rushes are in wetter areas for the most part. And drier areas are going to actually be mostly grasses.
Is it regional? It sounds very British, sedges and rushes.
Those common names may be British, but they're everywhere. I mean, they're actually, a couple of those groups are really diverse in Canada and sort of in Michigan specifically. There was like a lot of sedge heads up there. Some botanists get really into sedges and they're extremely hard to identify.
Sedge heads. That is sick.
I don't think I've ever heard that term before. I just made it up.
Well,
don't like enter a conference and be like, where are all the sedge heads, bro?
I mean, I would probably have just as good luck doing that as anything else.
A lot of the grasslands have really high plant diversity. So, for example, there's one patch of tall grass prairie called Kanza Prairie Biological Station. And there's over 100 grass species there and 400 other plant species. And it's not a particularly big region, so 500 species of plants in this relatively small prairie reserve.
Right on.
And there's often really high, it's called fine scale diversity. So in ecology, if we're measuring diversity, you have to like make a plot and count all the species within a plot. So really small plots, like 1 by 1 meter plots, and a lot of grasslands can have 30 species or even up to 50 or 80 species in a 1 by 1 meter plot.
Yeah.
So tons of species packed in a really small area.
Really cramming it in. Is it just anything? Could be insects, different plants, whatever?
That's just plants.
Oh, just
30
plants.
plant species. Yeah.
Wow.
30 to 80 plant species.
So it's like every blade of grass is a new species.
Basically, yeah.
Yeah.
I've done some plots in South Carolina that are 20, 30 species for sure.
Wild.
And really a large amount.
Now that's what I call biodiversity.
Exactly. It seems it's sort of the experience of actually doing that is a bit eye-opening. Like we actually have to look at a 1 by 1 meter plot and count everything. It's like, man, I never would have known there was so much here until I actually did it. It's
nice. That was actually I think Bio 180, aka Bio 101 lab that we did. One of those early classes where 100 level classes where we would take probably one by 1 meter plot and just like observe everything. I mean, we didn't know, we weren't like able to identify every single plant species or whatever, but it was basically like, you would look at it for like a certain amount of time, like an hour or something like that. And you would kind of like, I don't know, the point was, halfway through, you're still like discovering new stuff, even though it's this relatively small chunk.
Nice. Yeah. It's a good practice.
Yeah. Good work, you the bio teachers.
A healthy grassland will often have not a whole lot of leaf litter buildup. So when you get all these herbaceous plants growing, dead leaves and stuff can pile up. But a healthy grassland normally doesn't have a lot of that. And that's often because of either fire or grazing, which limits that.
Mm-hmm.
When that leaf litter builds up, it often decreases the diversity of grasslands because lots of plants can't get enough light to grow through it.
Okay.
A lot of grasslands will have a lot of below ground biomass. So if you think of a forest, all those trees, all that wood and stuff is biomass, and a ton of it is above ground. But a grassland instead can have sometimes similar amounts of biomass, but it's all below ground. So they have really deep roots, big tubers, all sorts of things to store energy below ground is a common theme in grasslands. And then a lot of plants will reproduce by clonal reproduction. So instead of reproducing by sending a seed out and having it germinate, it'll send a root out or have a new bud or something. So vegetative reproduction.
Right.
And I think I mentioned a couple of times, most grasslands are maintained by some combination of fire and or grazing.
Yeah, you did mention that. Wait, one quick question on the clonal reproduction. Is that, I know sometimes at least species will have like options to sexually reproduce or asexually reproduce. Is that how, is it like they can do either, but they often clone, or are most of them only clone, or do you happen to know?
Yeah, I mean, most plants have the ability to reproduce by seed, but it's just in the ecological context, it just doesn't happen very much.
Okay, got it.
Probably because the ground is so packed with other plants already that there's just not a space for them to germinate.
Right.
So it just happens much more common that it's vegetative. But I think it's pretty rare that plants can only reproduce vegetatively.
Okay.
But, sure, some do. But,
yeah.
You go to most grasslands, things are producing seeds all over the place. So they're trying, but
right.
mostly not reproducing much.
Into your eyeballs and nasal passages.
A seed in your eyeball would be pretty unpleasant. Pollen is probably the more common thing.
Wait, what is a grass seed then?
Grass seed is a fruit, actually. It's, you have a little flower, and it, for a short stage, if you look at a grass flower, it's got a bunch of pollen on it, and then normally blows around by the wind, and then it develops into a fruit, which is the seed. It's just, it doesn't have, like other fruits we think of, like a berry, it doesn't have like fleshy bonus goods around it. It's just the seed. Yeah. But like if you look at a grass seed, all the like stuff that you wouldn't eat on the outside of it, that's like the equivalent of the fleshy part of a fruit. And the seed is just the seed.
Huh. Man, I'm just having trouble like picturing a grass flower. Are we talking like wheat? Like, is that?
Yeah.
Okay.
Yeah. So, a lot of our crops, most things we call grains are grasses.
Right.
And the seed is just the thing we eat.
Got it.
That's the seed.
Got it.
Except, in nature, normally that seed will be wrapped by what's called a gloom and these various other structures that are like, like not very edible. And then the seed is inside. Most of our crops, that falls off and we're left with just the seed.
Okay.
But yeah, if you go to grasses out and, in lots of grasslands, you can pull them apart and be like, oh, it kind of looks like a grain of rice.
Okay, cool.
Some grasslands are as grasslands because they're on very inhospitable soils. So it can be extremely sandy and dry. Or there's a lot of grasslands called serpentine because they're on these natural patches of soil that are filled with various toxic metals. And there's, really hard to grow on that, but there's a bunch of plants that'll adapt to grow on those toxic soils. And those are very unique types of grasslands that pop up here and there.
Mm-hmm. I wonder if those adapt in places that have like human-caused toxicity levels or something.
Yeah. There have been some cool studies on mine tailings where there's big piles of toxic soils, and then there's plants that have evolved like over a really short time span to be adapted to those mine tailings. So it's a very similar process to adapting to the naturally existing serpentine soils.
Okay, word.
So grasslands have been around for a long time. There's evidence that there's widespread grasslands that were grazed by ungulates. And an ungulate is?
A hooved mammal.
Nailed it. For about 20 to 30 million years. So 30 million years ago, there were grasslands, was maybe about the first origin of grasslands that are as we think of them today.
Cool. No newcomers.
Yeah, I guess it depends on your perspective. I mean, there weren't grasslands during the era of dinosaurs because, those plants hadn't evolved yet.
Mm-hmm.
So in that time frame, they're sort of recent. And if you look at a phylogeny of plants, an evolutionary tree of plants, grasses are all pretty young compared to many other plant families.
Okay, right.
But in time spans that we more commonly think of, they have been around for a long time, 30 million years. And a lot of the tropical grasslands have probably been pretty stable for about 2 million years, because in the big changes in glaciation and ice ages and stuff, they probably weren't shifted. So like here in Florida, it's estimated that it's probably been grassland for 1 million or more years potentially, because even when there's ice ages, those habitats still persisted here.
Word.
But, the grasslands in the Midwest, they were all, a lot of those were buried in ice in the last ice age.
Yeah. And for context, like how long humans have been around in that as a relationship to that.
Yeah. Humans are thought to have evolved in grasslands, and something similar to modern humans has probably been around for about 300,000 years or so.
Word.
And these grasslands around the world have become one of the most, or as a category of ecosystem, they are the most endangered ecosystem in the world.
Oh, really?
Largely because they're awesome for farming.
Right.
So like the tall grass prairie in the Midwest of the US, there's about 1% to 2% left.
Whoa.
Compare that to the Amazon, there's 40% left or something. So,
right,
or maybe more than that.
Like the Amazon is fine. Like leave the chop down as much as you want, man.
Well, I mean, in some ways that's not the right message, but there are some perspectives sometimes when you're like, oh, they're destroying their ecosystem. It's like, man, we destroyed our ecosystems
yeah,
2 centuries ago. So
right.
They're incredibly endangered ecosystems. And same with the longleaf pine savannas here in the Southeast, there's less than 1% that are like in good condition, remnants, never been plowed, and have good fire regimes.
Yeah.
So it's one of the most endangered ecosystems in the world.
Huh. Big bummer.
Yeah. Of course, because they're grasslands, there are some very unique things about grasses that make grasslands what they are. So when you think of do you think of anything about a grass? Like when you think of a grass, what do you think of?
I don't know. I feel like there's like the leafy part, which is like the blades of grass, like a lawn, like that feels like the leaf part. And then there's like that more circular hard part that like the kind of the wheat section comes off of. And I feel like, in the wild, there's those parts are around, but in more cultivated lawn type situations, those don't seem to like make it to that life stage or whatever.
Those are the leaves, and then the thin part that comes up that has the flowers and seeds on is called the culm.
Culm.
So they're very different. CULM, culm.
Okay.
So very different structures, and basically the culm is the reproductive structure, but the leaves are all coming out of a central location close to the ground.
Yeah.
And they do that because the meristems of the plant, so like the parts where new growth comes from, are at or below the ground surface, which just to hear that maybe doesn't seem super important, but you compare that to most other plants, a shrub or most other plants, the meristems are out at the tips, up in the air where the new leaves are. So they're out in the open. And so if it got cut down or whatever, those meristems would be gone. Mm-hmm. But in grasses, the origin of life for a grass is down at or below the soil surface.
Okay.
And that makes them very resistant to burning and grazing.
Right.
Because you can chop off the oldest materials all up high. You can chop all that off, and where it grows out from is still surviving there close to the ground.
So is one individual making many of these different meristems that are shooting up leaves and culms and stuff?
Yeah, grasses come in two basic forms. There's bunch grasses and sod-forming grasses. And so a bunch grass is, I don't know if you remember being down here in Florida or in South Carolina, you often see these like clusters of grass amongst kind of sandy areas.
Right.
Where it's just like one bunch.
Yeah.
That's a bunch grass. And they're like very contained, and there'll be like one central meristem, and it'll shoot out a bunch of grass blades from that. Mm-hmm. And it can kind of look like a firework shooting out in all directions.
Right.
And then sod-forming grasses are like the types of grasses that lawns are made out of. And they're more like individual. There's like a bunch of individuals all together that are each forming their own little meristem with a few grass blades coming out of it.
Word.
And so another thing about grasses is they have these pretty unusual roots. They're incredibly fibrous. They're not like woody or anything. So they're small, but they're really, really tough. And they like fill the ground. If you've ever like dug up grass, like there's just this super dense network of roots. and that makes them really efficient at capturing water.
Yeah.
And for some other fancy physiological reasons, they're also really good at drought tolerance. And I don't really even remember why that is, but they're really good at capturing water and surviving really low water.
Nice.
It has to do with the way their roots are.
Yeah. Well, if there's a lot of root mass, then they can, never mind. I don't know what I'm talking about.
The drought tolerance is a more complicated thing. It's like how much negative pressure they can have, something like that.
Yeah.
And then another fairly unique thing about grasses is they have silica in their leaves, which is one of the things that makes a grass leaf like it is. It's really stiff and tough.
Yeah.
So it's actually like, it's a silica compound, and that's evolved presumably as a defense against grazing herbivores because it basically grinds down their teeth over time. So it's like this kill them slowly type of defense against grazers. And the presumed reason why grazing animals evolved the teeth they did, these big grinding teeth that kind of regenerate over time.
Right.
And horses can just like get to where they can't live anymore because their teeth are ground down and they just can't eat.
Bummer. Like, man, lay off the gluten.
Lay off the grass. And then one other cool thing about grasses is there's what's called C3 and C4 grasses. You ever heard of that?
I have, yes, but I cannot tell you anything about it, but I have heard of it.
So most plants in the world have a type of photosynthesis called C3. And so the C has to do with like the physiology or the chemistry of the photosynthesis results in 3 carbon molecules as an intermediate. Mm-hmm. So it's just like a jargon of why it's called that. And so most plants in the world are C3. Mm-hmm. And it has, the way the chemistry works is that it becomes less efficient as the temperature gets higher, which is just like basically a fluke, a limitation of that type of photosynthesis.
Right.
And so they just do worse when it's high temperatures, and they're also not super water efficient. So during photosynthesis, most of the water a plant uptakes is lost through transpiration, which is when they're taking in carbon dioxide, they also lose water vapor through their stomata.
Right. It just sort of evaporates out when they're open.
Yeah.
Right.
And C3 is does that a lot, just by the way it works. However, about half the species of grass in the world have what's called C4 photosynthesis. So it has 4 carbon molecules as an intermediate. So it's more complicated. And this type of photosynthesis is more efficient in hot, dry conditions. So it doesn't have that problem where it gets less efficient when it's hot. And through some magic, it also doesn't lose as much water to transpiration.
Nice. Magic is always good.
Yeah, I learned all how that works, and it's too boring to explain, and I don't remember it. But it's enough to get the gist of it.
Too long, didn't read, doesn't matter.
Right. So basically, in really hot, dry areas, normally you'll have mostly C4 grasses. And a cool example of this is the Midwest grasslands going from Canada down to Texas. In southern Canada, there's about 20% C4 grasses in northern Canada. And then once you get down to Texas, it's about 100% C4 grasses.
Oh, okay. So it's just sort of like a gradient.
Yeah, and there's a trade-off. So the more complex C4 photosynthesis doesn't do as well when it's cold for some reason. Probably just because it's more complex. The advantage is lost because it's not as efficient in that case.
Yeah.
So that was new to me. I didn't know that was neat.
That's cool.
Yeah. A lot of the grasses here in Florida, I believe, are C4, the dominant grasses.
Right, because it's hot.
Hot and dry.
I vaguely remember restoration having a lot of talk of C3 and C4 grasses.
Yeah.
Would that make sense? Where you kind of
Yep.
decide okay, what is the environment? Which one should we plant based on, I guess, the climate and everything?
Yeah, exactly. I mean, a lot of times if you're doing those restorations, getting the right grasses established is really important. And so knowing in that, given the soil conditions and the climatic conditions, which one to focus on. Sometimes you get in prairie restoration, often you get early on domination of some of these really common C4 grasses to such an extent that it suppresses other plant species. So it's big blue stem in the Midwest is a common C4 grass, and it just dominates. And there's sometimes a lot of efforts to try to be all right, big blue stem is great, but in moderation. And how do we balance out some C3 grasses, and all of the other flowering plants.
Right. They're just slam dunking on everything the entire time. You're like, all right, we got to even the playing field a little bit.
Totally. Yeah. A lot of the restored prairies I saw in Michigan were just like almost all big blue stem.
Right. And you're like, okay, good work, guys. Good work. Whatever.
Right. There's no big blue stem in team. Or whatever. I don't know. Fire. Let's dive into fire a little bit.
There is a team in big blue stem. Anyway, okay, go on.
There is stem, team. Is it really team? ST? You could jumble it up and make a team for sure. So.
Yeah.
So fire. I sort of hinted at fire a couple times. So grasslands are great for accumulating leaf litter. And so you get big piles of this leaf litter, and you have dry conditions, and you have big open landscapes. It's all the great ingredients for fire. And most natural fires normally start by lightning. And so how much fire there is in a region is partially a factor of how much lightning there is in a region.
I have never thought about that.
We have tons of lightning. It's the most lightning in North America is in Central Florida.
Oh, really?
So that's partially why grasslands evolved here, is because of so much lightning. In the Midwest, you also get big thunderstorms in the summer, and that brings lightning, that brings fire.
Cool.
So yeah, the types of plant communities that evolve and establish in certain parts of the world is partially a function of lightning frequency.
Huh. Should we bring in a meteorologist to tell us about why the lightning differentials are there? Nope.
I definitely don't have the answer to that.
Yeah. Too long, didn't read, doesn't matter.
And so the fires will tend to kill trees because they don't have that cool meristem trick that grasses do, where grasses and a lot of other prairie plants or grassland plants will be very resistant to fire. And that's partially due to those vegetative reproduction, the buds that are, they call them bud banks instead of seed banks. So there's just lots of buds waiting to grow back.
Yeah.
And then also all that below ground biomass is resources for them to resprout after a fire. And a lot of trees can't do that. So fire is a big thing that keeps trees out of grasslands. Prescribed fire, so like starting fires on purpose, is now an incredibly important management tool for keeping grasslands and maintaining the diversity in grasslands. So like the Nature Conservancy, they buy up land, but now one of the biggest things they do is work on burning much of their land because it's needed to maintain the ecosystems and the biodiversity in those regions.
Yeah. Counterintuitive, but
yeah,
that's why you ask the experts, not the amateurs.
Right. Fire is tricky. Too little can cause problems, but too much can cause problems in some cases too, because it can lead to only grasses dominating because they're often the most resistant to fire. So in some cases, when you burn too much, it cuts out all of the most diversity is not in the grasses normally, it's in all the other species. And so too much burning is problematic sometimes. Also, when you get into animal conservation, burning is sometimes at odds with plant conservation because, if you have a rare butterfly or something and you burn the whole thing, it's like, well, you killed all the butterflies.
Yeah.
So there's some interesting conflict there sometimes. And it's tricky to, that's one of the biggest debates in managing grasslands is how often to burn, where to burn, how big a patch is to burn in the hot season or the dry season. And the outcomes will depend on the soil, soil nutrients, the water availability, grazing, all sorts of other things impact the outcomes of fire. So it's really complicated.
Seems like it.
And then grazing, of course, can have very similar effects. It can prevent trees from establishing, and it can change the plant communities for 4 reasons. One is selective consumption, because grazing animals are all very selective. They'll eat some stuff and not other stuff. So the things they're not eating will be benefited. Big animals clomping around compacts the soil, and that can have unique effects. They cause lots of soil disturbance, especially bison. They'll make these big rutting things where they dig up the ground and roll around it and stuff.
Yeah. Sounds fun.
There's unique species that'll only grow in those, basically bison wallows.
Wild.
And then they change the nutrient availability because they're essentially chomping up the nutrients that's in plants that's not available to other plants and then pooping it out and making it available to other plants. So they're often increasing the nitrogen availability and more generally just like changing the nutrients in the system.
Yeah.
And just like fire, the effects of grazing are super variable and complicated. They can be beneficial in some cases and problematic in others. But they also interact with fire. So there's this whole field of study called pyrrhic herbivory, which is like specifically about the interactions between grazing and fire. So like in savannas, for example, like in the savannas in Africa, a common pattern is that a patch will burn, and then all the wildebeest and other big animals will come in right after that because they love the fresh growth right after the burn.
Oh, yeah.
So in managed landscapes, sometimes they'll actually move around cattle that way. They'll burn one area and then they'll just naturally move there to go graze it. And so they can help determine where the cattle are grazing through fire.
That's wild. They're like, we don't need cowboys. We have these people that like to light it on fire.
And I'm sure that's all knowledge that, indigenous people knew because they were starting lots of fires as well.
Yeah.
And for lots of similar reasons, most likely.
Right.
And natural grazing animals will tend to move around because of fire, for rain, or all sorts of other things. Of course, when we pen in livestock, they're not moving around. And they're normally at higher abundance, or often at higher abundances than wild animals would be. So too much grazing often has detrimental effects remember when we went to Big Bend National Park?
Yeah.
And all of that driving up to Big Bend's just a bunch of empty nothingness. And it was all kind of boring looking. And right when we got to the park, it was all fenced off. And there was just this beautiful, like 6 to 10 foot high vegetation, all this cool stuff. And that was just because there was a fence and there was no cattle grazing within the park. It just like totally changed the vegetation of the landscape.
Right.
And you can see that all over the place if see where there's fences and not cattle, and it just changes everything.
Right. But would that be like inside the fence would not be grassland? Would be another ecosystem?
Well, they would probably they're both grasslands because there wasn't like trees in either of them, but like where there wasn't all the cattle, there's all of this like cactus and all these other taller plants that were really interesting.
Yeah.
That were just, probably cut down and then not able to grow back because of all the cattle.
Right. So sort of just like a more diverse, healthy ecosystem of grassland when it's not overgrazed. Right.
And, as we sort of hinted at the beginning, what we call grasslands isn't always what we think of as just like a prairie full of grass.
Mm-hmm.
Savannas are grasslands and they have trees.
Mm-hmm.
There's just not very many trees.
Right.
And between all the trees, there's just a low layer of understory plants that's often dominated by grasses. But that's why a lot of these ecosystems don't really spark in our head as being grasslands, but in the broader definition, they fit because it's not dominated by trees.
Yeah.
And then finally, conservation of grasslands. As I mentioned, they're one of the most endangered ecosystems in the world. And one of the big problems is that grasslands have a lot more trees and shrubs in them because of lack of fire and grazing. And then another huge problem in grasslands is invasive species. And so many grasslands that have been disturbed by agriculture or grazing or other things have become dominated by invasive species. And invasive species are often the biggest problem to restoring grasslands.
Mm.
Eventually, we'll get to talking about California grasslands, which is like the world's most extreme example of that.
Okay. Yeah, it seems very tricky to extract invasive species from a grassland.
Yeah, they're just like, you can't easily just like go out and pull them out. There's just plants everywhere.
Yeah.
So it's almost always down to like large scale management, burning or grazing or things that they hope will cut down on the invasive species. And given all that conservation issues, restoration is a big thing in grasslands. So the most common type of restoration for grasslands is in abandoned agricultural land. That comes with all sorts of issues because you have these legacies of agriculture, which are normally increased soil nutrients, often increased phosphorus, and a bunch of weeds in the seed bank, and then changes in the soil microbes, and then just like very few of the native species around left. Mm-hmm. So if you just leave it, you would get what's often called an old field, which is like most of the areas that most humans get to see that they think of as grasslands are really old fields. And they're just kind of like whatever weeds popped up after an agricultural field was abandoned.
Huh, yeah. Interesting.
And so can be pretty tricky. And actually some of the better restoration practices are never let it go to that old field state, go directly from intensive agriculture where you're suppressing all those weeds and then seed in right into that agriculture is actually a pretty good, somewhat counterintuitive method because it helps prevent those weedy plants from having a big start at the beginning, like is the case in old fields.
Yeah. So you're like, start with a pumpkin patch and then go straight into full-on grassland.
Yeah. So yeah, there's some prairie restorations where it was an old field and they'll actually cultivate it with GMO soybeans for a while where they can spray with Roundup for 1 or more years and just like try to kill as many of the weeds as possible and till it and spray and then seed in prairie directly. And that's actually one of the more effective methods.
That's so insane. That's very cool.
Yeah. And so the goals of restoration are variable. And so, the goal we would most commonly think of is maximizing native diversity, which is normally assumed to be the goal of restoration, but sometimes it's different. Sometimes it's creating the right structure for an animal. So like a nesting grassland bird, maybe you're not as concerned what exact plant species are there. You just need the structure.
Right.
Sometimes it's like carbon sequestration, having a healthy grassland to store carbon, or it could be water retention or soil preservation, things like that.
Right, like functional uses.
Grassland restoration could be functional things or biodiversity things, often combination.
Mm-hmm.
And yeah, because there's so little of most grasslands left, without bringing in plants or seeds, you can't do it without it because they're not just going to disperse in because there's none left.
Right.
So bringing in seeds and plants is typically necessary.
Mm-hmm.
Normally, a pattern with restoration is that there's a few species that'll do really well, like I was saying with the big blue stem in prairies. And then there's often many, many species that are really, really difficult or nearly impossible to establish.
Yeah.
And that's just, there's lots of research trying to understand why, and might do with soil microbes, it might do with all sorts of things. You get all the complexity of ecology happening of why that might be the case.
Yeah. Those are officially called tricky buggers.
Exactly, yeah. And diversity tends to decline over time in restored grasslands, and why that's the case is not really well understood either.
Yeah, well, I mean, it kind of makes sense because if you bring in everything that you want to be there and then some of it doesn't make it, then that would decrease the diversity, right? I mean, maybe it's something different, but...
The pattern that must be happening is, like you said, you bring in a lot of species and a lot of them are going to be really rare. They might be there at the beginning, but because they're so rare, they just blip in and out and then they disappear.
Right.
Then the question is like, well, why are they rare? And all these other things gets into more mechanisms that we don't know so well. Like, is it because they don't have the right fungi in the soil or not the right pollinator? There's lots of other things that could be happening.
Yeah. I know that the biodiversity of my houseplants decreases over time.
Yeah, there you go. You're attempting to restore plants, whether they're native or not. Probably not.
Some of them, couple.
And then another growing understanding of restoration is that they can be really strongly impacted by random events or chance events. So like, how rainy was it the year you put the seeds down can have a lasting effect even decades later.
Oh, wow. And
more research now is sort of showing that to be the case, which is really hard to do anything about, but realizing that is a lot of the unexplained variation of why some are successful and some are not may often be due to these early events of, rain or herbivores or whatever happened really early on that shapes the trajectory even decades down the line.
Yeah. File that research under interesting, not helpful.
Sort of. Well, that pretty much rounds out my introduction to grasslands in general. We're going to take a little break and we'll be back to talk about old growth grasslands right after this. Welcome back.
Thank you.
Have a good
Wait, are you welcoming me back or the listeners?
I don't know. It's kind of one of those things. It's like you hear people from, radio saying things like that. So I feel like that's what I need to say, but it just doesn't really make any sense. So,
yeah, no, I think it does make sense, but it just I shouldn't think that it's for me. I think that's the main confusion.
We're speaking Presumably we're somehow both speaking to an audience and to each other.
Right. Welcome back. Not me.
Welcome back.
Yes.
Welcome back to Naturistic Radio, where today we're talking about old growth grasslands.
Nice. I'm glad it's more of like an NPR style than like a morning radio thing.
So old growth grasslands, ever heard that term before?
I have not ever heard that term before. I've heard the separate terms separately.
Yeah. So old growth, what do you normally think of?
I think of trees.
Mm-hmm.
Yeah, old growth forest would be definitely like probably the only time I've heard the term old growth. With, like, I don't know, big old redwoods and Northwest, Olympic National Forest, massive trees that you can drive cars through. I guess that's more the redwoods again, but yeah, just like hundreds of years old, basically.
Right. So big trees, old trees. Any other meanings that you associate with that?
Coolness, magicalness.
For sure.
Maybe some hidden fairies or gnomes or something like that.
There's a sacredness to it.
Yes.
And that's actually, I had something about that coming up. But so old growth forest, typically all those things, big old trees, and sort of a more clinical definition would be that it has no history of logging or agriculture or other large scale human impact.
Yeah.
Or at least European human impact. I think, indigenous peoples' effect with old growth, it gets slightly more complicated, but, the type of impacts we often think of cutting down trees and, large converting it into all these other things.
Right.
There's lots of forests that I think people think of as big and magical, but they're secondary. So is in the opposite, or the inverse of an old growth forest is a secondary forest. So it had been cut down and it's growing back as a secondary forest.
Yeah.
And if you don't know what you're looking at, you may not sort of recognize the differences.
Yeah.
Until often you actually see an old growth and you're like, oh, this is what it was. Now I feel sad.
Like you thought secondary was cool. You haven't seen nothing.
Yeah, exactly. And I would say most people on the earth have never seen an old growth forest or an old growth grassland.
Interesting.
And so the idea of thinking of old growth grasslands is a bit, I would say, even contentious or at the very least sort of unfamiliar.
Yeah.
And that one of the big reasons is for a long time in ecology and sort of among common knowledge is that grasslands is what we'd call an early successional community, which means like there was some disturbance, and as communities go through succession from one type of community to another, it would go through a grassland and then it would go to something like a forest. So that the grassland was just the early stage into something better and more magical that would come later.
Yeah.
Which is, given what we've now said about grasslands, can kind of probably see that that's a pretty flawed idea.
Mm-hmm. I respectfully disagree.
What do you disagree with?
Oh, with the grasslands being an early stage to just being to being something else. I agree with you.
For sure. Right. It's like, are we going to have to battle this out? Grassland battle, go. So an old growth grasslands are really easily overlooked or ignored because they can be classified as degraded forest or because you'd be like, well, this should be a big forest, but it's a grassland, so it's not anything special. And then the other issue is there's no easy way to identify an old growth grassland. You can't go measure tree diameter like you can in an old forest and just be like, oh, it's old growth, or take tree rings and see how old the trees are.
Yeah.
There's no easy way to do that with the grassland because a lot of the magic is below ground or really complex things like what collections of species are growing there or how the soil microbes are, how the soil nutrient, all the stuff that's like, well, there's no like easy way to just kind of look at it and say, oh, that's old growth.
Right. You can't just like pull up the archival satellite images and go back a million years.
Yeah. I mean, although you can't go back that far, satellite images have been very important in identifying patches of grassland because you can go back far enough to see that, well, when there was the first satellite image taken, there was no agriculture here.
Right.
And that's enough to sometimes tell you, well, that likely was old growth, or it could be.
Yeah.
And actually the study I work on in South Carolina where we have Actually in our study, we've never called them old growth grasslands, but I guess we could. We always called them remnants, which is its own kind of confusing term, but they're patches basically that never had agriculture. And one way we know that is that the first plane photos, they're not satellite photos, the old aerial photos show that there was never agriculture there. And right next to it, there was. And that's actually the basis of our study is we have areas where there was agriculture in 1940 or whatever, and there wasn't in 1940. And presumably before that, there wasn't in those areas either.
Right. I guess that would work well for North America or for the New World. Probably a little bit trickier to know in Europe, but there's probably also not as many grasslands in Europe, I would guess.
Oh, yeah. There should be, but there's not many left.
Yeah.
There are some really cool studies looking at abandoned agriculture from Roman era. So they can tell by artifacts and things that there was agriculture there like 2,000 years ago or something.
Yeah.
And they still see lasting effects of that agriculture on the plant communities today.
Wow.
In those studies as one of the coolest examples of agricultural legacies. They see elevated phosphorus in the soils still from the manure they added to those plots thousands of years ago.
That's so insane. They're like checking the Old Testament for like, they're like, yeah, that lines up, still messed up. Yeah,
it must have. I mean, I don't remember how they delineated what regions were and were not, but
yeah.
However they did it. Probably, I'm guessing it's more, based on archaeological evidence and stuff.
Yeah. Just for any biblical scholars out there, I do realize that 2,000 years ago would be New Testament, but it was just a joke. It's exaggeration.
So the idea of old growth, like you said, can help foster conservation because it evokes ideas of diversity, of uniqueness, of beauty, of sacredness, of cultural importance, of just kind of awe and wonder. So I think that term has been very valuable for forest.
Yeah.
And could be just as valuable for grasslands.
Yeah. Definitely more convincing than remnant.
Right. Yeah. We're actually, the whole project I worked on, we called, or still call it, I guess, the Remnant Project. And we've slowly kind of realized,
that doesn't sell grasslands.
An additional difficulty in conserving these grasslands that we would call old growth grasslands is that they're often maintained by fire. And still fire is seen as bad or unnatural. So it's a weird thing to say, well, this is a sacred, amazing ecosystem that we should preserve and let's go burn it. It just kind of doesn't compute very well with most people, I think.
Yeah.
And then grazing and can be difficulties as well, because cattle could actually be used as a tool in some cases to help preserve these areas that are seen as old growth, which also feels weird.
Right.
Like, why would we release cattle? But if there's no bison or other natural grazing animals around, they can be a reasonable substitute, but it needs to be very delicate with it. You need to know about the ecology, how many to have, what timing to have it, all sorts of things. So it's a weird kind of dynamic and can be counterintuitive and strange to argue that this is an amazing, pristine ecosystem, but we're also going to put some cattle on it and burn it. Like, what?
Like, I've got my pack of goats and my flamethrowers. Let's go. Let's go to our sacred grounds and really do them what they deserve.
Right. Just punish them. And so there's also a pretty strange modern thing that's threatening old growth grasslands, which is this idea of carbon sequestration. So there's big government programs and things to plant trees, or normally the idea of increasing carbon in the soil comes in the form of planting trees. Mm-hmm. That's what you do. Plant a billion trees. It was a big thing on YouTube early, like last year. There was like tons of channels had this thing about planting 1 trillion trees. Mm-hmm. And that's cool. It's a great idea. But one of the problems with a lot of those initiatives is they say, well, if we took all of the areas where trees could be and we planted them all, we'd solve our carbon problems. But a lot of the areas where trees could be are grasslands where trees shouldn't be.
Right.
And so...
Damn you well-meaning hippie YouTubers.
And there's a situation of that in the UK where there's like these northern like tundra bog ecosystems where they're like, oh, we get carbon credits for planting trees. So they drained these bogs and then planted trees. And it was just a total disaster. And then the trees were all dying. And it was like, this is like totally ecologically out of bounds, doesn't make any sense, just because the idea of planting trees seemed good. And so the restoration in that case was going to cut down the trees. And actually the restoration in the studies I work in is also cutting down trees. Yeah. So, you know, the project we both worked on in South Carolina, the restored patches were clear cuts. And so it's like, wait, what? We often had to be really careful explaining our experiment. Like the restoration was bringing in big machinery and cutting out all the trees. It's like, wait, what?
Yeah, very counterintuitive.
And so these grasslands can be seen as great opportunities to increase carbon sequestration in the short term. And we're thinking of like big trees, all this above ground carbon. But, you know, those areas often aren't great at supporting trees. So in longer term, there's much more likely to be a fire that burns up all those trees, or there's a drought or various other things that, like, in the long term, that carbon's probably not going to stay there because there shouldn't be trees there in the first place. And when you compare that to grassland carbon storage, which can be really, really high as well, that carbon is stored much more securely because it's almost all below ground. Yeah. And so you get these huge roots and all this organic matter that sometimes just gets broken down and part of the soil is like there almost permanently at that point, where a tree is actually a more fickle, comparatively, storage of carbon.
Interesting.
Can burn up tomorrow.
Yeah. So you need to start a new campaign where you plant 1 million blades of grass across the world.
Well, I think, you know, large scale grassland restoration is part of that. And there's, you know, starting to be some more research on, you know, the amount of carbon sequestration that is involved in that and things like that. So, you know, grassland restoration is definitely becoming a thing. And I think the more we think of it as like, there's other benefits to restoring the ecosystem that should be there, that you just have to be a bit more in tune with what that ecosystem should be, right, given the conditions.
Yeah. So I'm thinking a better plan is, instead of planting trees everywhere where they can grow, shift that model to plant trees everywhere where they historically have grown and without displacing other important ecosystems.
Exactly. Yeah. I think that's the main, you know, there's this huge paper that was all about, you know, modeling the effect of planting trees and all that. And the main rebuttal from all the grassland people is like, wait, you're talking about converting all the grasslands to forests. That's lunacy. Yeah. And it's a pretty simple modification. Just like, well, don't suggest planting trees in a bunch of places where trees shouldn't be. Yeah. That's not always as easy to figure out as it sounds. I mean, there's lots of places where trees shouldn't be that are covered in forest now. So do we go cut them all down? And, you know, that's more complicated. Right. But, you know, at least incorporate the idea of the existence of grasslands into the idea.
Totally. And like, yeah, the concept of like should and shouldn't be certain things probably gets extremely impossible like immediately once you start using that kind of like thinking and language.
Yeah, it goes back to, you know, I was in introducing restoration before, I presented it as in response to whatever your goals are. So restoration isn't always return it back to what it was. That's kind of maybe the most intuitive thing. Yeah. But restoration in practice is just achieve your goals for you know, a system of plants and animals and things.
Right. Yeah. One of the things that I sort of remember from restoration class that I took at UW was sort of like practical restoration, like how, like ideally everything would be, you know, the way it was before humans messed it up, but like how practical is that? Is that doable? Is it going to take $20 billion to do something that's not really going to have that much of an effect? So like it's, you know, often a better method to take a functional approach. And it also is easier to convince municipalities and humans and taxpayers and all these, you know, whatever nonprofits and stuff that like this, we're going to do this because this will have this positive effect on all these other, you know, even like directly affect humans, you know, filter water or whatever, you know, filter air and all these different things. So it's like you can sell it better. It's easier to do. And it's like, if you're an idealist, then you're basically never going to get anything done because it's just everything's going to be a problem.
Yeah. Setting your goals is always a complex balance of pros and cons and feasibility versus. And one couple of things you said introduce this idea of there's sort of two broad models of restoration and conservation. One is ecosystem service model. And that's kind of like what you're saying, like, well, you could maybe put a dollar value. It, has this many tourism dollars, or it saves water filtration by this much, or prevents this much flooding or whatever. Mm-hmm. So that's one model, which is, in terms of the world of conservation, pretty new idea. Mm-hmm. It's sort of economic idea. And then the other is more just like intrinsic value. Like, well, we should save it because it's cool.
Right.
Like, because we don't have the right to destroy all these species. Biodiversity, because of its uniqueness and irreplaceability, should be conserved for its own sake.
Yeah.
And there's sort of a delicate balance between those sometimes. Mm-hmm. And I think leaning too hard on the ecosystem service model, I think, is fraught with difficulty because, like, well, what if we could change the value and then it's not useful anymore?
Right. Like, oh, we invented a really excellent water filtration system, so we can now destroy all of the marshes or whatever.
Right. Yeah. One other factor that helps get to the idea of an old growth grassland is longevity of some of the organisms that live there. And so in some grasslands, there are species that have been documented to be over 500 years old. So these are plants they're just like a, flower, like a plant that doesn't look like a giant old tree, but it's half a century, half a millennium old.
Wow. An individual is that old.
Yeah.
Yeah. Wow. That's really wild.
And then the idea of individuals gets a little more complicated, especially when you have all this vegetative reproduction, because you sort of clonally move over time.
Yeah.
But in Florida, a common understory plant in the grasslands is called saw palmetto. It's basically a really short palm tree with spiky leaves.
Yeah, I took many photos of those.
They're very photogenic and they're beautiful and also very sharp.
They will saw your palmetto right off.
Exactly. And there's evidence that some clusters of those may be up to 10,000 years old.
Whoa. That is really wild. Yeah.
The majority of tall grass prairie plant species in the Midwest of the U.S. are probably have a lifespan of less than 20 years for a lot of them. Mm-hmm. But still, they're mostly still considered long-lived for a perennial. I mean, 20 years for a little flower still is quite a long time.
Yeah.
But many of the bunch grasses may frequently live much longer than that, although it's really hard to know because they're sort of clonal and spreading and stuff.
Right.
But potentially quite common that they're living for centuries. But then to sort of throw into the mix, these grasslands that may have plants that are hundreds of years old will often have really short-lived species as well. When you have these disturbances, you have bison digging up the soil and you have fires and gophers and all these things causing disturbances. You'll even have annuals going in those little pockets, living amongst plants that are maybe a century old. So it's complex.
Right. It's like the way that Sun Ra would do his band, where he would have like some guys that had been with him from the beginning who are like old dudes, and then he'd have some guys who are like the young, fresh energy who are like just getting going, and then he'd have some people in the middle who had like maybe been with him for maybe a couple decades, but like not from the very beginning. Yeah.
Got to mix the geezers with the youngsters.
Yeah. Keep like, fresh ideas, new concepts, new things, but also like keep the groundwork of some important kind of keystone blowers.
I like that. I'm seeing a new complex metaphor between tall grass prairie and Sun Ra. There's an essay there somewhere.
Yeah, definitely. Got to get one of those philosophy of science guys to do something about that.
Yeah. If we want an outlet for some psychedelic music and weird trippy visuals, maybe that's a future project for us.
Nice.
So all these ideas of old growth grasslands kind of have lots of support here and there. The ideas make sense. There's lots of concepts that make sense and anecdotal evidence of old plants and all these things, but there wasn't really a good test of the idea of an old growth grasslands. And so the question for this research project is, are old growth grasslands unique? and more diverse than human-disturbed secondary grasslands. So to answer that question, this study did a meta-analysis. And so that's taking a bunch of studies that had been done previously and analyzing them all together. Mm-hmm. And so it was 31 studies on 6 continents, and each of them was looking at a secondary grassland following human disturbance and comparing that to a nearby old growth grassland and seeing if they was able to recover up to similar as the old growth.
Yeah.
So that's like a natural experiment to test this idea of the uniqueness of old growth grasslands.
Lucky that they had 31 of those floating around to grab from.
Yeah. One of the studies in this meta-analysis was the project I work on in South Carolina.
Oh, cool.
It's kind of cool. So yeah, there's been quite a few of these studies, luckily. And so the main take home is that across all these studies all around the world, the secondary grasslands were missing 37% of the species compared to old growth. So if an old growth had 100 species, the secondary would only have 63.
That's not great.
No. And because these studies all varied in age, they were able to make some predictions of like how long it might take. And they found that if you sort of extend the air bars of the study, maybe within 100 years, you're starting to get closer to full recovery. But if you really take it strictly, it may be as much as 1,000 years before you're consistently getting full recovery of the number of species.
Wow, that's too long.
Yeah. It's a little hard to be super confident about that number because there weren't 1,000-year-old studies there. They had to extrapolate.
They were referencing the New Testament for that one.
Yeah. So they're pretty confident that within 100 years, we're not reliably getting full recovery, and normally not.
Yeah.
And maybe is hundreds or even 1,000 years to get full recovery. But that's just measuring richness. That's just the number of species that are present. Because you can have 2 areas that have the same number of species, but they're still incredibly different. So it's a very crude measurement. And actually, the project I work on, there wasn't differences in richness between the 60-year-old the abandoned agriculture and the old growth savannas. So they actually had similar richness, but the compositions were very different. So that's like what collections of species are they sharing the same pool of species? Those were very different.
Okay.
And so there was a subset of studies, including ours, that they were able to do that type of analysis on. And so they very clearly said that the recovery of composition will take much longer. Even among the grasslands that were predicted to have similar recovery of richness, only 43% of the species were shared. So it's not even halfway there.
Yeah.
So when we're saying it might take 1,000 years for the richness to recover, who knows how long it might take for the composition to recover.
Right. You still might be missing a majority of the species that were there before.
Yeah.
Yeah.
And their data suggests part of that is that the secondary grasslands have lots of non-native weedy species, which is not surprising, but their data support that idea. So the younger the secondary grassland was, the higher percentage of the species were weedy or non-native.
Yeah. It almost feels like cheating to count those.
Well, exactly. Yeah. I mean, that's one reason why you can sometimes get recovery, quote, recovery of richness, but a lot of the species in the secondary are all these things that maybe shouldn't even be there.
Right.
And sometimes they're weedy but native. And so it's hard to exclude them by any criteria,
right.
but like they may not ever be common or even present in sort of the old growth habitats. And then the other thing that they found was that the old growth grasslands tended to have a lot of these species that weren't in the secondary, specifically ones that are long-lived, fire-adapted, or poorly colonizing. So they don't produce a lot of seeds. All those things all those adaptations we talked about before are the types of species that are missing in the secondary grasslands.
Yeah.
And so from all that, this is really amazing, worldwide evidence that the old growth idea of grasslands is very real. This idea makes perfect sense. These are amazing ecosystems that are delicate and fragile and should be preserved. And they argue that these old growth grasslands should be given equal conservation priority as old growth forest.
Cool. How much momentum does this movement have?
Well, I don't think a lot.
Is Justin Trudeau on board yet? Or like what? Any celebrity endorsements?
So. No, I don't think so. I mean, even among ecologists, he's sort of got a bit, this crowd has got a bit of an uphill struggle.
Yeah.
You know, there was someone on Twitter posted this study and was like, what this idea of old growth grasslands, this is really intriguing, but does it really fly? Does it really make sense?
Yeah.
And so, you know, there's definitely pushback that it's like, I think just because it seems so weird and counterintuitive, it just doesn't sit with people. And this idea of grasslands being early successional isn't just like a flawed idea among corrupt politicians. Like that was the dominant idea among ecologists. So this idea of grasslands as a really important place for biodiversity and having long-term developments and all these things is still pretty new and definitely not broadly accepted.
Yeah. Well, here we are to spread the word to the masses. Hear ye, hear ye.
I do wonder, like, if it's a bit of an uphill struggle to get ecologists to think of this idea, how much more of an uphill struggle is it for, you know, a policymaker or some NGOs and things like that?
Yeah.
I don't know.
Well, it's like phase 1, right? I mean, you got to start somewhere. You got to convince the ecologists, and then step 2, step 3, profit.
I think so often my take home for a lot of things, whenever I learn about a new system or unique biodiversity, it's like there has to be priority in preserving what isn't already destroyed. Yeah. Because as much as restoration is great, like it's real difficult. It's really difficult.
Yeah, totally.
And like you're in for a long haul, and you know, centuries or millennia to maybe get back what was lost.
Yeah.
If you're lucky.
Right.
And so maybe that's become common idea for forest, but I've gone out of my way to try to find patches of old growth tall grass prairie. Like I've driven across the entirety of Ohio and Indiana, and you have to like do some deep Googling to find where there's a tiny little nugget, and it's like a little cemetery that's surrounded by fields. It's like 100 feet by 100 feet. And you go there and it's like, oh, this is what all of this should be. And this is the only tiny little sliver that's left.
Whoa.
It's bonkers.
And that's the cemetery, or that's just near it or something?
Yeah, one I went to was like, there's a cemetery and then there was a plot. It was like people weren't buried there, but they were going to. It was like a future cemetery place.
Right.
But instead of ever tilling it, they just kind of grazed it or mowed it a little bit. So it was able to keep a lot of those native species. And then eventually the Nature Conservancy bought this tiny little plot, and you can drive up to it. It's like a little roadside attraction, this fenced off thing. It's like, this is it.
Wow. Are they still going to bury people there?
I doubt it. But it'd be maybe a real expensive. You donate $500 million to the Nature Conservancy, maybe they'll let you.
Yeah. You can be buried there, but you just can't have a coffin or a gravestone or anything.
Natural burial.
Yeah.
There is a cool cemetery here in Florida that's a natural burial, and it's also like a dual purpose as like savanna restoration.
Yeah.
So it's a really cool mix. So their dual goal of providing end-of-life services while promoting native biodiversity.
That is very cool.
Yeah. There could be a lot more of that in the world.
Yeah. There is hope for the future.
Yeah. Another place where there's often little slivers of old grasslands, that one of them I've been to is along railroad lines. So it would just be these little slivers where it's like too close to the railroad to plow up. And then as a cool little quirk, the trains would shoot off sparks and sometimes start fires. And so accidentally there would be like keeping the natural fire disturbance there. So there's a little one I went to that's like maybe 1,000 feet long or something, that's maybe 10 feet wide. Like that's the only patch of remnant prairie is this tiny little strip on the edge of an old railroad line.
That's so wild.
Yeah.
Thank you to choo-choo trains. We owe you everything. Yeah.
An ode to you, choo-choo. Cool. That's what I got. Is that any other like thoughts or feelings about grasslands, changes of view of the world that came from that?
Yeah. I mean, I definitely have a changed view of the world and grasslands after learning all that. And yeah, I mean, I feel like if there's any takeaway for me, it's like just the level of importance of grasslands and how threatened they are. And even just like, I mean, it almost feels like how little people care about it, including possibly a lot of scientists and ecologists and stuff.
Yeah. Yeah, they're the underdog. They're the most destroyed and the least respected.
Yeah.
They're the Harvey Dangerfield of ecosystems.
Yeah, there's the show subtitle.
If we had merch, that might be our first t-shirt.
Yeah.
Some silhouette of him tugging at his collar.
Yeah.
And then like standing in an old growth prairie.
And you have field in the name too, which really...
Oh yeah. There you go.
Old field. I like that term still.
No respect.
Yeah.
Cool. So we have one more section on grasslands that we'll get to in the next episode, which is about California's grasslands, which are a pretty stunning example of a lot of the things we talked about. And we'll get to that next time.
Word. Sounds good. Thanks for the knowledge.
Cool. Yeah. And thanks for listening, everyone. If you have any thoughts or questions, email us at
naturisticseries@gmail.com.
And what else? Anything else?
Check out the videos and tell your friends.
There you go. And we'll see y'all next time.
Peace.